Our other power theorems deal with secants and tangents. The first type we'll look at is what we call a secant-secant power theorem, and then the second type we'll look at in this video is the secant-tangent power theorem. So, the first one, in a secant-secant power theorem, we have two secants. That means they go through our circle all the way outside and they intersect it twice. It creates two segments. And the key to our secant-secant power theorem is the idea that we have a piece, one segment that is outside the circle and a segment that's inside the circle, but then we also have the segment that is the entire segment, the entire secant. And that's the other one that we're key on, that we have to key on here. So the outside part, in this case 2, and then what I'll call the entire secant. Those are the two things, the two pieces that we are going to multiply anytime that we're dealing with a secant. So in this case, I know I have a secant where the outside piece is 2, and the entire secant, this is an addition problem. This is segment addition. The entire secant is not 2x. It's x plus 2. So when I have a secant, I'm going to take the outside piece times the entire secant length. I'm going to set that equal to, my other piece here is also a secant. It has an outside piece, which is 4, and it has an entire secant length of 12 plus 4. Well, if they're like terms, do the addition. Don't write 12 plus 4 down here. That's equal to 16. Write 16. Now I can solve this algebraically. I'll have to use the distributive property. 2x plus 4 equals 64. Subtract 4 from both sides, and then divide both sides by 2, and x is 30. The second example has a very similar setup, so what I want you to do is go ahead and press pause and see if you can write your initial setup here for the second example. Hopefully you have this set up. X times x plus 3 equals 4 times 10. X because it's outside, x plus 3 because that's the whole secant. 4 because it's outside, the whole secant is 10. This algebraically is a little bit more challenging, however. Geometrically, that's the initial setup. That's what we have to understand about this theorem. But algebraically, now when I distribute my x, I get x squared plus 3x equals 40. I can't square root both sides here. These are the problems we have to solve by factoring, using the zero product property. So if I subtract 40 from both sides, I get x squared plus 3x minus 40 equals 0. Now I have to find my actual factors. Square root of, so x squared is x times x. What multiplies to negative 40 and adds to positive 3? My coefficient is 1. That is going to be an 8 and a 5. One of them has to be negative. Since the 3 is positive, the 8 is bigger, the 8 is positive. Those are my factors. Then the zero product property says that x plus 8 is 0. That means x is negative 8. Or x minus 5 is 0 and x is positive 5. The geometry then comes into play, and we have to look at x is a segment length. The segment length cannot be negative, so x can't be negative in this case, and x is 5. The next thing we're going to look at are secant-tangent power theorems, and what's nice about secant-tangent power theorems is our secant is going to be identical. Anytime we have a secant, we're going to do the exact same thing. The only difference now is that I have a tangent which doesn't have an inside, outside, it's just all outside. So because in our secant we use outside times the whole thing, and that's for a secant. For a tangent, the entire thing is outside, so it's really just outside times the outside, or the whole thing times the whole thing, which in this case is going to mean we're squaring it. You're always squaring your tangent functions, and you set those two equal to each other. So outside is 4 times the whole thing, which is 9, is going to be equal to x times x, or x squared. So algebraically, and I'll just switch these so it looks a little bit more familiar, x squared is equal to 36, square root both sides, and x is 6. Not negative 6 because my segment can't be negative. And then this next example is going to be very similar. Outside, which is x, times the whole thing. Again, be careful here. It's not 12x. It's x plus 12 or 12 plus x. I like to write the variable first. And that will be equal to the entire tangent, which is 8 squared. Again, this is a trickier algebra problem. X squared plus 12x when I distribute equals 64. I have to get this equal to 0, so I'm going to subtract 64 from both sides just to save space. When I take 64 minus 64, I get 0. I have my factors of x and x. And now I need to figure out what multiplies to negative 64 and adds to positive 12. So what we find is that we have 16 and 4, and since the 12 is positive, positive 16 times negative 4 is negative 64. Positive 16 minus 4 is positive 12. And once again, zero product property. X is negative 16, but x is a segment length, so it's not that. And x minus 4 is 0, so x is 4. X is 4.